let's move on to our third speaker, Mr. Sondip. I call upon Mr. G. Erumalai, Council Member Chennai Chapter, to introduce Mr. Sondip to a gathering.
It's giving me immense pleasure to introduce our third speaker of the day, Mr. Sondip, Solution Manager, Ferrous Coatings, Foseco India Limited. Mr. Sondip have Mechanical Engineer, Advanced Diploma in Foundry Technology, MBA in Operation and Marketing. He has 4.5 years Foundry experience in steel industry and 13 years experience. He is working in 13 years in Foseco India Limited. He started career in Foseco India since 2010 as a application engineer in sand system solutions. Looking after application of different type of binder system closely associated with the process conversion from silicate to alpha set, then worked for ferrous coating application for more than 4 years. Now working as a solution manager for ferrous coatings past 5 years, providing coating solution and services to Indian foundries. Responsible for end-to-end business and support foundries with innovative solutions. Sir, the floor is yours.
Thank you very much, sir. First of all, for your kind introduction. I need not to explain anything more. Hello everyone. Very good afternoon to all of you. I'm going to take you through about my topic, that is advanced coating technology for automotive foundries. So before going through the content of this presentation and the body of this presentation, I'd like to congratulate IAF Chennai chapter for this special day that we are together here to celebrate this special day, that is chapter day, 38th chapter day. And thank you very much for giving us this opportunity to showcase one of our case study with respect to how we are actually working with our partner foundries to develop new coatings, which is actually helping them to get better casting qualities. And my previous speaker, so there are 3 speakers actually. Our chief guest, Mr. Nanathan, he talked about all development and then innovation, then sustainability, and how it is actually implementing and it's going to be future for that. Then Ms. Priya is talking about emotional intelligence, and then Mr. Venkatesan is talking about AI, artificial intelligence, how it is going to be future for Indian foundries. So starting with the content of my presentation, I'll be talking about basics, current market scenario for automotive foundries, mainly demand and supply, and then automotive iron casting new requirements for them, and how actually casting defects is impacting to get such kind of casting requirements or specifications for the foundries, and then what Foseco we have developed, and then type of defects we have eliminated through, and upcoming defects which are because of this upgradation and specific requirements coming forwards and foundries are facing, and how we have developed new coatings and solve these problems, and what we are looking forwards in moving ahead, how we can work together and help to the foundries. So if we talk about the demand supply and then foundry current market scenario. So in today's scenario, Indian foundries are making name in global market for the quality, for making quality castings and supporting them with respect to on-time delivery, and they are competing with global players because we are upgrading ourselves, are upgrading process quality and the consistency. At the same time, delivery is one of the aspects that is looking for the global markets. So if we see in quarter to quarters in last year and starting of this year, quarter to quarter, the demands are increasing, but there is always uncertainty with respect to the demands as well as the quality requirements. If we see in post BS6 implementation in 2019 and 2022, the casting wall thickness, the requirements of casting wall thickness, especially in case of critical components like cylinder head, block, the engine started evolving, and then internal passages thicknesses are reduced. So mainly to lighter the weight of the engine and then supporting the EV norms to better lower emissions. So to get such kind of casting quality, so we need to do some improvement in terms of internal passage clearness, and then casting quality specification, specifically those defect-free castings in internal passages and no kind of porosity. Those are the norms I'll be talking about in later stage. And we have seen there is a lack or challenges to get skilled manpower after COVID scenarios. So overall, if you see, in challenging situation, every challenge is an opportunity for us to develop, which actually pushes us through to develop new things, which actually helps to the foundries. So in also all possible areas, how we can evolve and which can also develop good quality castings and support to the market, as well as reduce the cost to be competitive in the market. And that is what we majorly looked into. One of the important area, that is fettling area in final processing area. How fast foundries are moving their castings from fettling area, that is the area talking about the foundry quality, consistency, and then the upgradation in the quality. So if we talk about new requirement in particularly casting specification, castings area, because of this internal cleanness, internal cases, zero sand fusion, zero veining, or no scab is acceptable. In porosity level, if you see, there is no porosity in particularly water jacket and bore core area, bore areas specifically. And then return particles matters. This is one of the important parameters we have been talking in last few years after this PS6 implementation mainly. So the degree of cleanness or internal soundness of the castings is defined with respect to the millipore value. So millipore value is we talked about the retained particles or the residuals remain inside the passages after final cleaning of the engine components. So when the casting is completely clean, and then we pass through some liquids and then clean it through that liquid, either it is some portion of solvent and then mixed with water, and then we check how much is the retained particles, so residuals. So that we measure in milligram. So that is what that retained particles matters comes in millipore value. So nowadays foundries are talking about for a particular size of castings, different castings are having different specification, like 50 milligrams, 70 milligrams, or in case of block castings, they are looking at 150 to 100 milligrams. So these are the specifications for different type of castings. So now this kind of millipore value getting is difficult because the wall thicknesses are getting reduced. And in case the tolerances we talk about in water wall thickness variations is not accepted more than 1 mm. Critical component like turbocharger and volute castings, volute area, so there is no tolerance above 3 microns. So these are the specifications. And dimensional tolerance, no bulging kind of thing. So to get such kind of specification, to meet such kind of specification, foundries started working on their process also. So we should have minimum rejection, even zero rejection, zero repairing, and then to adopt that, to get that, we should have some kind of automation, robotic application. Then only it is possible to achieve such kind of quality requirement. So foundries started adopting this kind of stringent norms for their process in core shop specifically, and the process WIP we say the stock of cores should not be more than 1 shift. So in case we see automotive foundries, they are using cell core and cold box cores. So the long is the storage time, the rejection is more, the bulging tendency or the dimensional deformation tendency is more. So that is what we talk maximum 1 shift. So overall, if we see, these are the complex requirement, as well as this increasing complex, along with this increasing complex requirement, high performance automotive castings in large volume specification is one of the important. So overall, if we see, to get automotive in this castings quality in automotive segment, if you see, the core area is one of the important area. So where the Novec systems, PUCB binder system is using, along with coating. So if you see, there are three major things is used: sand, binder systems, and coating. And we call coating is one of the vital and major important aspects or raw material, input raw material, because coating is directly coming into contact with liquid metals. So the coating quality, good quality coatings will give you good quality castings, and then that is what coating plays a major role. So we have seen in earlier days, earlier presentation also, I have covered many defects how we are eliminating through new developed coating like veining, metal penetration, sand fusions, written particulate matters. I have spoken about millipore value in my last presentation also. I have talked about millipore value. So now, because of this thin wall casting, now one of the upcoming defects, the challenge facing by the foundries, automotive foundries mainly, core side scab defects, mainly with cylinder head block. Not only critical, the regular castings like chunky castings, housing castings, structure castings. So we'll be talking about this thing. Started actually last year when one of our partner came forward and started discussing about this upcoming scab problems. Started with general purpose castings like housing, not that critical castings, and then they talked about cylinder head and cylinder block casting, where also they have started facing this kind of problem. What was happening? They are facing bottleneck in fettling area. It was very difficult for them to fettle this kind of castings because of this scab defects, which was randomly and coming with few major castings, where the foundry was making about 4,000 metric tons of castings following PUCV binders process and using conventional process. So for them, it was difficult to dispatch the castings as per the their OEM requirements. So if you see, these are the kind of scab they were getting from the front side as well as in the deep pocket area. So for the for foundries, it was difficult because it was not possible to remove this kind of scab by chipping. So they had to grind it and then reprocess it, and then again short blasting. So process were increasing. So we all know why the sand scab defect is happening. So because of sand expansion, and then at elevated temperature, the scabs are two types. One is expansion scab, another is erosion. So once is expansion happened, then it swell, and then because of metal static pressure and force, it's wash it out. So two types of sand happened, two types of scabs happened. So the major parameters, if you see, those are playing major roles. This is sand, type of sand, AFS we are using, distribution of the sand, fines, percentage fines. So more the fines, so higher the binders requirement, more the tendency of bonding strength. Then lower the permeability, then there is a chance of gas pressure creation, and then again expansion, and then scab creations. So if we see high quality sand is being used the foundry, then there is a tendency of more expansion, and there is also chances of scab defects. So sand plays a major role, binder also plays a major role, and then coated core strength. After coating, water-based coating on core, there will be a drop of strength. So in that case also scab can happen. So that is what relative humidity and then temperature also plays a major role. Many times we have seen that these kind of defects are possible to eliminate through methoding. So that is what hotspot design and then runner and riser design also plays a major role. And then lastly coating. So coating, if you see in foundry, the contribution of coating is hardly 1.52% of the all other raw materials. So its significance consumption wise, if we see, it is very less, but the significance is very high. So that is what we have realized. So initially, before discussing with us, the foundry started looking at all possible areas like sand testing, process check, and their standards, and then they have process core mold making, core making, and then incoming resources, everything they have checked, and then bench life, step time. They they have also done coating benchmarking, different type of coating they have tested for this type of castings. They looked into methoding, they hotspot, magma also they looked into, they consult with, and then they have conducted with different trial with respect to different permutation combinations. But it was difficult to eliminate. So when we discussed with the foundry, then we asked, or we actually started working together, and then we suggest, let us do experiment, do one castings without coating and do one castings with special coating. We have some insulating coating, and then we tried. So these are the images of two different castings. One left side, if you see, the coating was, the casting was poured without coating applications. And then specifically another castings where that special coating was applied. If you see casting results, so first casting, no scab, but casting came out with sand fusion, and the second casting was not having sand fusion, but the cap shifted in other areas. So that means we understood that there is a role of coating, and coating can play a major role here. So we started working with our global team, and then we started developing new coating. So whatever the initial trial we had done, that was just a demo for that. So we had to develop a suitable coating. So we consult with different raw material suppliers, different manufacturers, and then mines, as well as we consult with our global team. And then different type of coating formulated. So whenever we formulate some coating, we actually benchmark these coatings through casting test. We have a special process of testing this coating through benchmarking process. Means we make core, we make mold, and take it to the nearer foundries or partner foundries and pour them and see the casting results. We benchmark them. We compare with our existing coating, all high performance as well as general purpose coatings, and see whatever the requirements, whether it is performing in that way or not. And then we started getting one of the input from the group that we have already one established process to actually identify or witness or test the coating for scabbing. So we consult with our Netherlands team, and then we understood there is a standard process for testing the coating for scab defects. So this is a small video. Just watch it carefully. It will be very difficult to understand, but there are slides which I'll be explaining how scab is happening. No, there is no audio. This is just video. So there will be a constant supply of gases, and pressure will be created in the, and then small crucible, small specimen will be coated, and then it will be putting at furnace at 900 degrees centigrade, and every second the measurement, you can see the spotting from that particular location. So what is happening here? Because of so you see that particles is coming out from that particular locations, and it is creating a scab in the particular location where the coating is applied. So even at metallurgistic pressure and flow, similar kind of thing happened. So that is what we tested different coating after our developments, and then we found one of the coatings started working perfectly, and then we took it to the foundries and tested through. So from this test also you can see with continuous flow, after this puncture the pressure is reduced. So these are the castings, housing castings coated with newly developed coating. The foundry, they have a large tank of 3 metric ton and 2 metric tons, and then these coatings are cores are coated with robotic dipping applications at a viscosity of 15 to 16 second, maintaining 250 300 microns of build-up, and then the castings you see. Clean casting without any scab, as well as very clear internal passages also. No sand fusion, no scab. So Foseco, we have a range of high performance coatings for this kind of applications, for millipose value, for eliminating veining, sand fusions defects, and these developments are done with the help of all of you, expert foundrymen. So thank you very much for your support, continual support, because without your support coming to us and then partnering with us, it was never possible for us to develop such kind of coatings. So we'd always thank you, support, and come up. We also learn from you. So that is the way we actually working and developing. So our objective is raising the bar continuously and support to the foundries to new developments. Keep enhancing the casting performance and reduce defects rates and improve the foundry performance. So I talked about, so these are the now new challenges coming to us for cylinder block castings. Now if you see the foundries, they are making cylinder block castings wall thickness of 3 mm, where in earlier we were talking about 1 mm tolerance. Now they will be working for making 3 mm wall castings. So there you can understand the clearances. So for that also we have developed similar coating. So maybe in next presentation I'll be taking it through and covering that part. But my thanks and request to all of you, if you have such kind of problem, we can work together. Let us come forward, and the rest of the day I'm available, so we can work together and create a better foundry and solve these kind of problems. So many thanks for listening. If you have any questions, I'm here to and happy to address.
Any questions?
See, mainly automotive foundries, they are using water-based coatings. So these coatings are available in water as well as solvent-based. So any coating, if it is available in water, it can be made available or can be made available with solvent. There are 3 major components in coating, 4 major components: filler, carrier, binders, and suspension, other additives. So main roles is filler and the binder systems and the rheological conditioner. Those are the elements plays major role. Carrier can be changed whether it is water or alcohol.
What the base is, like aluminum silicate or compact?
The conventional coating we talked about, it was aluminum silicate based coating, but the advanced coatings are mixed refractory. We can say it's alumina and special other raw materials, it's a combination of different raw materials, like we can say I can say it 1-to-1. But it's see, even if I tell about the raw material, whether it is alumina silicate, graphite, pyro, mica, or whatever it may be. So I have told already 5 raw materials name. But it is not possible for anybody to actually formulate or evaluate it in that way. So it is not that confidential. So but formulating and then tuning it with respect to the casting requirement is very important. So that is what this casting test and testing of these coatings is very plays a major role. Thank you, sir.
Any more questions? Thank you, Mr. Sondip, for taking us through various casting defects, how coating can help in eliminating those defects, and the new developments in coating. Now I invite Mr. Balamurugan, Council Member Chennai Chapter, to felicitate Mr. Sondip with a traditional Angavastram, and Mr. P. Sendil Kumar, Honorary Secretary, to felicitate with a memento. Thank you, sir.